Good morning, guys. So, following on from last lesson, where we thought we knew that earthquakes, every single one, cause major damage, but we actually figured out that earthquakes all have different sizes and are measured by the what, Julia? The Richter scale. Well done. So, what did we do to figure this out? What did we do? Did we do an experiment, an investigation? Did we go on the computers? What did we do? Alex? We did an investigation, didn't we? What did we actually do, Cooper? So we built a mini city, and it had trees, small buildings, large people, cars, people. We had everything in there that a city or a town would have. And what did we actually do to that city? We didn't just look at it and say, oh, that's so pretty. What did we do, Jack? We shook it, and we didn't just go straight to the large one. We went small, medium, large shapes. And what did that tell us, Matilda? Yeah, so we learnt that each earthquake is different, and they don't all have to cause major damage. Sometimes it's just as small as a little shake, and some people will feel it and some people won't feel it, but other times they cause major destruction. Let's quickly have a quick recap and look at our photos that we did last lesson, and we looked at, and we tried to guess. We did a prediction, what we thought it would be on the Richter scale, and then we actually got the real one. So, Matilda, let's have a look at that. Where do you think that earthquake damage would sit on the Richter scale? About a 3? Yeah, let's see if you're right. It was a 4, okay? So it had a magnitude, a Richter of 4, okay? So it could be felt by some people, but there was minimal damage. What about this one, John? About a 7? Yeah, let's have a look. 7, well done. So it's pretty major, there's some pretty major damage. You can see the road's all torn up, it's going off and doing whatever it wants. What about this one, Alex? A 9. Very well, I agree. It is a 9. Well done, guys. You guys seem to be all over understanding that Richter scale. Okay, let's quickly jump over to our Walt-Wilson tip. So we are learning to recognize what causes earthquakes, including understanding tectonic plates, which you guys will be introduced to. Locate different earthquakes that have occurred all around the world. I'm looking for students following procedures safely when completing investigations and compiling observations and drawings in your science journals, which you'll have a chance to have a go at today. This is because it is important to understand the risks and consequences of earthquakes in hope to have positive outcomes in natural disaster education, and also for next week's lesson where we actually start to discuss the different Earth's layers. Okay, so let's have a quick look over our TWLH chart. Last lesson we looked at all earthquakes and their damage and the Richter scale, so we're moving on to this one today. So tectonic plates, this is what we think we know. Tectonic plates are underneath the water and move with the current. What we want to know is how tectonic plates move. Okay, so everyone, I want you in your tidy trays to grab out your science journals, and I want you to sketch or write, so describing. So you can sketch, which I want a labeled diagram, or you can use words, say whatever you want, and I want you to describe what you think tectonic plates are, or how you think earthquakes actually occur, okay? And we'll come back and I'll hear what you have to say. Okay, John, can you tell me what you decided to do in your science journal? Yeah, okay, so you thought, because you learnt in science that heat creates energy and makes things move, so you think that earthquakes only occur in hot countries. Great. So that's actually in our next segment where we talk about, you guys told me that earthquakes only happen in hot countries, and we want to find out, do they actually occur only in hot countries? So well done, John. Okay, we'll talk about that later. Emily, what about you? What did you decide to put down? Okay, so you agree. You think with this statement that we created a couple lessons ago, tectonic plates are underneath the water and move with the currents. Okay, we'll talk about that now. So it's actually the crust, which is our Earth's outer piece, which we'll learn about next week, okay? So don't stress if you don't understand all this terminology yet. So it's that Earth's crust which is broken up which creates our tectonic plates, okay? And these fit in like a jigsaw puzzle. So they match really well, okay? So these tectonic plates the world used to be the Earth used to be one big continent. But 200 million years ago, so a very, very long time ago, the plates started to split apart. And they haven't stopped moving since, okay? But we can't feel these tectonic plates moving as they only move at about a fingernail. Like it's very tiny when they separate. So sometimes when the Earth shakes, and that's when our earthquakes occur, okay? We're gonna quickly talk about some new terminology. So we're gonna add some new words to our word wall that you guys might like to use when you're talking about things in your science journal. So first we've got convergent plate boundaries, okay? So that is when the tectonic plates are moving towards each other. So they're coming in like this. And sometimes that's how mountains are actually created. So when they're moving in, what do you think they're going to do? They're probably not just going to stop. What do you think, Cooper? Yeah, they're going to push up against each other. So does that look like a mountain being created? Exactly, okay, so that's what a convergent is. And you can see I've added a little photo there for you guys to remember. Okay, the next one is divergent plate boundaries. So still talking about those tectonic plates. Okay, so can anyone have a guess what they think that might be about? Ali? Moving apart, well done, great guess. So we've had convergent, where they go together, and divergent, when they go apart, okay? Well done. And our last one is transform. Can anyone guess what transform plate boundaries? So we've had gone together, we've had gone apart. Brody, what do you think the last one might be doing? Going past each other. Well done. So we can add that one to our word wall as well. All of those have a photo to help you guys jog your memory. You're not expected to know this straight away, okay? And this is why we have the word wall, so you guys can go back to it. Okay, so everyone find a group of 3 quickly. We're actually going to have a go at this experiment, this little investigation. We're going to use an egg, okay? So what we've got here in your groups, you should all have a boiled egg. You need to be sensible with this. So what we're going to do is just lightly tap to make cracks. Ali, what do you think these cracks are representing? Those plates. What are we calling those plates? Tectonic plates. Well done. So we've got to use that terminology. We've got to get familiar with it. So first, what we're going to do is we're going to replicate our convergent. So we're going to slowly, taking turns with the people in your group, we're actually going to move the pieces of eggshells or the tectonic plates together. So what's happening when we push them together? Can someone tell me what's happening? Okay, so you can see that the parts of the eggshell, some of them are breaking apart, but they're pushing together. They're being forced to push against each other and sort of create a mountain, aren't they? Okay, pass it to your next person in your group. Our next one, divergent. So, Julia, what are we doing? Pushing apart, well done. Okay, so we grab it, and we're actually gonna spread it apart. What actually happened? Just gentle, guys. Yeah, so you can see our tectonic plates, they're spreading apart more, aren't they? They are. So they're starting to get wider and split and create diversion, otherwise known as the changes to the Earth's surface. Well done. So can you guess what we're going to do next? The transform. Well done. So everyone just slide the pieces of eggshell past each other. Some of the eggshell might come off, that's okay. Just go to a new piece. So can someone tell me what's happening? So they're sort of grinding together, aren't they, Zach? Yeah, well done. Okay, so what I want you to do, go back to your tables in your groups. I want you to get your science journals and I want you to draw what happened. Use diagrams, use words, use labels. Tell me what happened with your eggshell, okay? All right, thanks guys. Okay guys, so you've written in your science journals, you've used all this scientific terminology that we've been working on, you've drawn diagrams and you've labelled them, you've showed me what you learnt with the eggshells representing the tectonic plates. We're going to move on now. In your same groups of 3, I want one person to come up and grab 2 pieces of Play-Doh. And what we're going to do, pretty much the same thing as we did with the eggshells, is we're going to practice understanding this terminology. So I want you guys to demonstrate in your groups the convergent plate boundaries, the divergent plate boundaries, and the transform plate boundaries. And I'm going to wander around the classroom and I'm going to check your understanding, and I want you guys to demonstrate to me what you've learned and the knowledge you know, okay? So go ahead. Alright guys, well done with that task. I was really impressed with how you manoeuvred the Play-Doh to resemble the tectonic plates, and you guys really demonstrated your understanding with using these words that we've added to our word wall, which is convergent plate boundaries, divergent plate boundaries, transform plate boundaries, and tectonic plates. Our word wall is coming along great. We've got some great words that are going to help you in your future science journals. Let's quickly finish off today's lesson with the TWLH chart, okay? So, Jack, can you tell me what we learned this lesson? Yeah, so the Earth's crust, which is the Earth's outer layer, is broken up to create our tectonic plates. Great words, Jack. Very impressed. Okay, and Cooper, can you tell me how did we do this? How did we learn this? Yeah. So we used plasticine and we used the eggshell that resembled the Earth's tectonic plates moving. Well done, guys. That was a great lesson.